I'm going to demo using these 6 steps to graph this rational functions, and we're not going to use table of values until dead last, and we're going to take each of these 6 steps independently. I'll start at the top with the x-intercepts, and we ask ourselves what takes the numerator to 0. Well, if we look at these, if we look at this value, if that's 0, then the value of that fraction is 0. Or if this is 0, the value of that fraction is 0. Let's take the easy one. If x minus 2 is equal to 0, then x equals 2. So we have the 0, 2, comma 0. We'll go ahead and we'll graph that over here, and that would give us that root, that 0. The other one, if 3x minus 1 equals 0, then that gives us the root x equals negative 1/3. So we have the ordered pair negative 1/3, comma 0. And so I graph that. And we know that those are the only 2 places that this curve could cross the x-axis, because those are the only 2 numbers that take the numerator to 0. Let's take the vertical asymptotes. We'll look at the bottom, and we look at these 2 factors right here. If x minus 1, if x is a value that takes x minus 1 to 0, then we would be dividing by 0. We can't have that, so x cannot be 1. So there's a vertical asymptote at x equals 1, and there's a vertical asymptote at x equals negative 4. And they're lines, so you write them in the form of a line. Here's one vertical asymptote at x equals 1, and here's the other vertical asymptote, 1, 2, 3, 4. So we're done with steps 1 and 2. Steps 3, f of 0 is equal to, well, looking at the very top up here, and we're subbing in 0 for everything, we're going to have a 1 times negative 2 over negative 1 times positive 4 is equal to positive 1/2. So for the value of 0 of x, we have a y value, f of x, is equal to positive 1/2. So we'll go over there and graph 0, 1/2. We're going to skip section 4 because I'm going to come back and erase all my work, and because we need a lot of space for that. So let's go on to 5. Consider only the highest power of x for the numerator and the denominator. The horizontal asymptote, we're also going to call that the end behavior. F of x is approximately the highest power of x in the top is 3x squared if we multiplied that all out. The highest value of x in the bottom is x squared if we multiplied those factors out. X squared over x squared wipes out, and we see that there is a horizontal asymptote at 3. The fancy way to say this is as x approaches both positive and negative infinity, so we're going to put them there at once, then f of x approaches positive 3. So for very large numbers of x, very large negative numbers of x, then our curve is going to approach that horizontal line. I'm going to take the eraser and clear all these marks. Number 4, behavior near vertical asymptotes. So here's how we're going to write this. We're looking as x values get closer and closer but never quite get to this vertical asymptote, the one at negative 4 from the left. We're also going to look at it as it goes closer and closer from the right. We're going to look at this asymptote from the left. We're going to look at this asymptote from the right, and I'm going to do it in that order. I'm going to say we're looking as x approaches negative 4 from the left. But what I'm going to write is I'm going to say as x approaches negative 4 from the left, what does f of x do? Okay. And here's what we're going to say. If you look at these factors up above here, we're going to look at them one by one. And we're going to imagine that we're subbing in a teeny bit less number, lower number than negative 4. Say negative 4.1. We're going to imagine f of negative 4.1, a little bit to the left. But we're not going to really sub that in. What we're going to the only thing we're going to do is we're going to say, is this positive or negative? 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 And you can see that for this one, if it's a little bit positive or a little bit negative of negative 4, if we subbed in negative 4.1 or we subbed in negative 3.9, a little bit to the left, a little bit to the right, that's going to be the same. It's going to be about negative 12 plus 1. It's going to be negative. We can look at the next one, x minus 2. If we sub in negative 3.9 or negative 4.1, it's going to be about negative 6. For sure, it's going to be negative. Same thing for this one. If we sub in negative 3.9 or negative 4.1, we're going to subtract 1 from that. It's going to be about negative 5. It's going to be negative. But here's where it's going to change. This value, x plus 4, is going to be positive if you would sub in a little bit to the right. Negative 3.9 plus 4 is positive, but negative 4.1 plus 4 is negative. So here's how I'm going to write it. So we're looking from the left. We're looking as x approaches negative 4 from the left. As x approaches negative 4 from the left, f of x approaches, let's look up at the top, negative times negative over negative times negative 4.1 plus 4 is negative. Okay, f of x is equal to positive. As x approaches negative 4 from the left, f of x approaches positive infinity. And here's how I want you to write that. I want you to put an arrow right there. As x approaches negative 4 from the right, we're imagining that we are negative 3.9. The only factor that's going to change is this one right here. I have f of x is equal to negative times negative times negative. Those are all going to be the same, but this time it's going to be positive. Negative 3.9 plus 4 is just a teeny bit positive. Okay, so f of x approaches, we look at this and we say f of x is equal to negative times negative over negative times positive, and we say that f of x approaches negative infinity. It goes down forever. So we look and we go to the right of our graph and it goes down. Now we'll look at the other vertical asymptote. As x approaches 1 from the left, we're imagining 0.9, and we'll erase this, and we're imagining 0.9. 0.9 times 3 is going to be almost 3, plus 1 is going to be almost 4. But also, let's do 2 at once. A little bit to the right of 1 would be 3.3 plus 1, a little bit more than 4. So we're going to say that no matter if we're a little bit to the right or a little bit to the left, for sure that's positive. For the second factor, if we sub in 0.9 or 1.1, for sure it's going to be negative. We're going to pause on this one because that's the factor that caused that asymptote. Therefore, that's the factor that's going to change. But let's look at x plus 4 right now. Who cares if it's 0.9 or 1.1, then this is going to be positive. So those are not going to change at all. So the factor that's going to be different, whether it's on the left or whether it's on the right, is this one. Because this one, if it's a teeny bit to the left, 0.9 minus 1, it's going to be negative. If it's a teeny bit to the right, 1.1 minus 1, it's going to be positive. So let's show our work. As x approaches 1 from the left, we're imagining 0.9, we have our f of x We have 3 out of the 4. We have positive, negative, question mark, positive. We're imagining 0.9, so 0.9 minus 1 is going to be a teeny bit negative. Negative over negative is going to be positive. So f of x approaches positive infinity. We go to the left of 1 because that's where we were calculating, and we make an arrow indicating that it's going to go forever when we are to the left of 1. And then we have one simple calculation. As x goes to 1 from the right, we're imagining 1.1, then f of x is going to go to, stays the same. This was negative, so now it's positive, and this one's positive. F of x will go to negative infinity. So we go to the right, which is where we were calculating, and we say as it gets closer and closer to this, it's going to go down. For number 6, we would look in the regions with the purple squiggles, and we would pick some exact points. Here's what we would expect. In the region to the right of the asymptote x equals 1, we know that it's going to go down forever, and we know that right here is the only place that it would pass through the x-axis. So we would estimate that it would do something like this, and then we know that it would approach this asymptote from beneath. In the middle section, between the two vertical asymptotes, we concentrate on these points right here. We know that it goes to the x-axis and the y-axis at those points. Further, we know that it's going to go up and it's going to go forever as x gets closer and closer to 1 from the left. It's going to go higher and higher. And we know that as x approaches -4 from the right, it's going to get lower and lower. So it's going to do some kind of squiggle like that. And then the last one, the last section, to the left of the asymptote x equals -4, we know that it's going to go up forever, and it's going to curve something like this, and we would expect it to approach that asymptote from up above. We would pick 2 exact points, and we would get xy values to confirm this, but I'm not going to show that on this video. Thanks, that's it.